Okay, today we are going to start on Unit E, which is all about trigonometry. So we're going to start by just some really simple reminders of things I hope that you already know or already are familiar with. So some of the basic things in trigonometry that you've learned so far would be your basic trig ratios. So remember, this is SOHCAHTOA when we're dealing with right angle triangles, which we're going to see a lot of in this unit. Remember that sine of an angle is equal to the opposite side divided by the hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. So remember that we label the sides based on their relationship to the angle. So if this is the angle we're working with, theta, then our opposite is across from it. Our adjacent is the side that makes up one side of the angle, and the hypotenuse is always the longest side or the side across from the right angle. We also have our cast rule from grade 11, which tells you which of these ratios are going to be positive in each quadrant. So CAST, cos is positive in quadrant 4, all the ratios are positive in quadrant 1, sine is positive in quadrant 2, and tan is positive in quadrant 3. A couple other little vocabulary pieces are just complementary angles add up to 90 degrees, supplementary angles add up to 180. That doesn't come up too often, but good little thing to be reminded of. Now, also in grade 11 PreCal, you learned about reference or related angles. Now, these are used to solve equations for all the angles between 0 and 360. So, a reference angle is basically an angle that's made up of a terminal arm and the nearest x-axis. So, for example, if I have a reference angle of 30, in quadrant 1, it's just an angle that's equal to 30. But in quadrant 2, a reference angle of 30 means I'm going 30 degrees from the nearest x-axis. So when I go up 30 degrees from this axis, remember that that would give me an angle of 150. And that's because this angle is 180 degrees. So if I go up by 30, I'm left with 180. Now, if I go into quadrant 3 and I go from the x-axis down 30 degrees, this is equal to an angle of 210 because I have 180 plus the reference angle of 30. And in quadrant 4, if I go from this nearest x-axis back 30 degrees, that's equal to an angle of 330 because it's 360, take away 30. So we have these general rules for these reference angles. So in quadrant 1, the angle and the reference angle are equal. In quadrant 2, the angle will be equal to 180 minus the reference angle. In quadrant 3, it will be 180 plus the reference angle. And in quadrant 4, it will be 360 minus the reference angle. So a few other little things to remember when you're looking at these angles here is that the starting position of the angle is called the initial side, and then we wrap around by whatever angle we're working with, and where we end is called the terminal side. And also, when we're working with these angles, we always go counterclockwise, and that's our positive direction. So here going counterclockwise is 150. If I go clockwise, that would be a negative angle. Okay, so when we go into grade 12, what differentiates the trigonometry unit in grade 12 is that so far you have only ever measured angles using degrees. But what we're going to start using now is another unit, and these units are called radians. So just like I can measure a length in either centimeters or inches, I can measure an angle in either degrees or in radians. So the key for measuring in radians is knowing that 360 degrees is equal to 2 pi. Now remember, 2 pi is equivalent to a number. So pi is 3.14. So that's here 2 pi is equal to approximately 6.28. Okay, 2 times 3.14. That is 1 revolution. So we're going to get into talking about the unit circle. 360 degrees is 1 full revolution in a circle, and it's equal to 2 pi, okay, or approximately 6.28. Now, if I do half of a revolution, I know that that's 180 degrees. That's equal to pi. So pi is 3.14. So 3.14 radians is equivalent to 180 degrees, or half a revolution. And I can keep dividing that up. If I wanted to do a quarter of a revolution, or 90 degrees, that's going to be pi divided by 2, or 3.14 divided by 2. And if I wanted to do an eighth of a revolution, I could take pi and divide it by 4 to get equivalent to 45 degrees. Okay, so if we look at some examples, one thing to note, and this is a good thing to remember, that now if an angle measure is given and there's no degree symbol, you can assume that it's in radians. So if I say the angle is 3.71 and there's no degree symbol, it means 3.71 radians, which is just a little bit bigger than pi, because pi would be 3.14 approximately. Okay, so if we are looking at these angles here, just some review of drawing these angles in standard position. First is a good review of the idea of a negative angle. So remember, negative is going backwards, okay, or clockwise around the unit circle. So this would be approximately negative 165. Remember, halfway around is 180. So if we were going positive 165, it would land here in quadrant 2. Negative 165 lands in quadrant 3. Now if I talk about my radian measure, if I have 5 pi divided by 6, remember pi is half a revolution. So pi is equivalent to 180. So approximate, or right there, approximately 3.14. If I want to do 5/6 of pi, then I'm going backwards. Think of this being divided into 6 slices. Okay, so 1, 2, 3, 4, 5 pi by 6. And if I had a radian measure of 1.2, well, remember, half a revolution is pi, which is approximately 3.14. So half of that would be 1.57 approximately. So if you were going to have 1.2, you would be around here in the first quadrant. Okay, I also included here, good to note, that 1.57 approximately, 3.14, 4.71, and 6.28. Those are your 4 primary radian measures for 0 or 360, 90 degrees, 180 degrees, and 270. Okay, now when you were looking to, the primary thing we're going to do in this lesson is convert between radians and degrees. If you are going from degrees to radians, what you're going to do is multiply by pi over 180. And that's because 180 degrees is equal to pi radians. So 1 degree is going to be equal to pi over 180. So this is what we're going to multiply by to convert between degrees and radians. So if you have 30 degrees and we want to change it to radians, I multiply by pi over 180. That's going to simplify you get 30 pi over 180, which simplifies to pi over 6. This is just like simplifying fractions. So 30 goes into 180 6 times. So that's how I've simplified that. Okay, same thing, 120 times pi over 180. Again, 120 over 180 simplifies to 2/3. So it's 2 pi over 3. 250, we would multiply by pi over 180. And again, this fraction doesn't reduce as much. It would just be 25 pi over 18. We can also convert a negative angle. And again, negative 300 times pi over 180. And this reduces to negative 5 over 3. So negative 5 pi over 3. You always want to leave these in terms of pi. So pi has an approximate value of 3.14, but we don't want to use that actual decimal. We want to leave it in terms of pi. Okay, same here, 270 pi over 180 simplifies to 3 pi over 2. And f is just slightly different. If we know we've got 2 1/4 revolutions, and we want to change that to radians, well, we know that 1 revolution is 2 pi. So here, what I did was I changed 2 1/4 to an improper fraction. So I've got 9 over 4 times 2 pi. And here, that simplifies to 9 pi over 2. You can also think of this as the 2 being 2 pi plus 2 pi. And 1/4 revolution is equal to pi over 2. So this is 4 pi plus pi over 2, which is the same as 8 pi over 2 plus pi over 2. So 9 pi over 2. Now if we want to convert from radians to degrees, we know that 180 degrees is equal to pi. So 1 radian is 180 over pi. So we would multiply by 180 over pi. Here, we've got pi over 4. I'm going to multiply by 180 over pi, and in this case, the pi's cancel each other out. You're just left with 180 divided by 4, which is 45 degrees. Here, 3 pi divided by 5 times 180 over pi. Again, the pi's cancel out. You can use a calculator for this. 3 times 180 and divided by 5 is 108. You can use the same method even if the radians are given as a decimal. So 1.8 times 180 over pi, you're going to plug this into your calculator, you get an angle of 103. Same if we have a negative angle, so negative 5 pi over 6 times 180 over pi is negative 150 degrees. Now you'll see here I wanted to give this answer as a positive angle, so I added 360. That's called a coterminal angle. And we'll go over that more in the next lesson. For these purposes, negative 150 would be an acceptable final answer. We'll talk more about coterminal angles in the next lesson. And then here, if I'm changing to degrees, 1/3 of a revolution is 1/3 of 360 degrees, so 120 degrees. That is the first part of the first outcome in this unit. So you can check out these practice questions, which will be some practice on converting between degrees and radians.